All right, guys, we're going to be working on some word problems. These are the first of the school year, and I want to get us down into kind of a rhythm and routine, kind of a format or structure, whatever you want to call it, so we can be better at being able to analyze and solve word problems. I feel like for a lot of students, even if they're good at math, these can be kind of a hang up or a struggle. And so I want us to have some more confidence and understanding in being able to answer these types of problems. All right, so I'm going to include notes later on in the slide or within the JunoPod, but I'll just read off these steps that I want us to follow when doing a word problem, okay? So step number one, you want to underline the question, okay? Underline the question because then that will help us understand, well, what answer are they looking for? Because there could be more information than we need or misleading information, so we want to know what are they specifically asking for, right? Or it might be there's multiple steps and you only completed one, but then you're like, oh, I didn't finish everything that was happening there. So I need to make sure I'm on top of that. The next thing is circle the important information, right? So you see numbers or important words, stuff like that, to make sure to look at those. Next, now this is, I don't know how I want to say this. I think a bar model is important, or some sort of visualization of sorts, some sort of image to help you kind of make the problem a little bit more real. Often that's done with something called a bar model, and I'll show you how we do those. But I don't know that it's necessarily mandatory that it look exactly the same for every single problem. There's going to be some we touch on that we just kind of diagram what's being described, and that gets us our answer. But I feel like they are, once you have an understanding of them, they become much more useful than you would think. Finally, and I think this is important, and this is one of the only times we'll really use cursive in math, is write the answer in a complete sentence. If they've written a couple sentences here to ask a question, then we'll return an answer in a full sentence, right? That's just like if someone was emailing you or texting you and your response was just okay, right? That it doesn't seem adequate, right? So we're not going to do that. We're going to give the full answer in cursive. So with that in mind, we're actually going to be working on word problems that are in the workbook itself, pages 63 through 66, because I could put word problems in the pod, but I think this would be an easier way to work on this, is to hear me kind of work it out with you and show the process. So let's go ahead and get started. Number one, Raphael has 118 baseball cards arranged in an album. Each page of the album can hold 9 cards. How many pages are full and how many cards are on the last page? So step number one, underline the question. What's helpful is almost always the question has a question mark at the end. So we're just going to underline that last sentence. How many pages are full and how many cards are on the last page? Step number two. All right, so let me show you that. That's what that'll look like. We're going to circle some important information. We have 118 baseball cards. That's important to know. Each page can hold 9 cards. And then I'm even going to circle within the question how many are full and how many are on the last page. Okay, so those last things you don't necessarily need to circle, but definitely the 118 baseball cards and the 9 cards on each album in each page. Okay, so let's think about this. We have a total, if I was going to draw that, and this is with a bar model, we have a total of 118 cards. Okay, and so that can be shown like that. I have a bar, it's worth 118. We know that it can be split into groups of 9, right? But what we don't know is how many groups are there going to be? We don't know that yet. That's what we're trying to figure out. All right, so if we have a big thing and we're separating it equally into smaller even groups, that's going to tell us to do division. So we're going to do 118 divided by 9. 9 cannot go into 1, so we're going to move on to the next digit. 9 goes into 11 one time, minus 9 gives us 2. Bring down the 8. All right, sorry about that. Quick pause. Back to this problem. So we were doing 118 divided by 9. 9 goes into 28 3 times. 9 times 3 is 27, so we subtract. We get a remainder of 1. So technically our answer is 13 remainder 1, but that step 4 says write the answer in a complete sentence. And let's go back to the question then. How many pages are full and how many cards are on the last page? So looking at our answer, it looks like there are 13 full pages and 1 card on the last page. So we're just going to write that. I'm going to write it in print so you can read it carefully, but at least at our school of preferences, you read it in cursive. There are 13 full pages and 1 card on the, I'm going to run out of room, last page. There we go. Okay, so let me get up nice and close. There we are. Number 2. Now this one has a little calculator next to it, which the book recommends use a calculator to solve this problem. Not going to do that. Nope. We are going to use our minds. We can solve this. I have done this problem, I don't know how many times, probably 30 different times, right? Seeing 3 math classes per year over the past. We've had these books since, I think, my 2nd year. So this will be my 7th go around. So yeah, we're getting close to 20 times at least. We can do this without using a calculator. A ski club had 146 members. Each member paid $30 a month for training fees. How much did the club collect in fees for the year? So again, underline our question. How much did the club collect in fees for the year? We know that there's 146 members and it's $30 a month, right? But they're asking for the year, so we want to, keep that in mind. So if we showed that, we would have 146 members. We know that there are how do I want to put this? Each box, how much do they collect total? Oh, no, I know how I want to do this. Okay, so there's 146. There's going to be 146 boxes. Each of these is worth $30. We don't know the total, but we know that the total, there are 12 months. I'm confusing myself with these. That's why sometimes it's not handy to have the boxes. But here's essentially what I've done. We know that there are going to be a total of 146 members. Each member pays $30, and they do so over the course of 12 months. We just don't know how much that total is going to be. I think the best way to do this is to take 146. Let's just find out 1 month. All right, 146 times 30. What's handy about this one is we can just throw that 0 down and just move on to times 3. 3 times 6 is 18. 3 times 4 is 12, plus 1 is 13. 3 times 1 is 3, plus 1 is 4. 4,380. That is 1 month, how much they make. But there are 12 months in a year, so we want to multiply that by 12. 2 times 0 is 0. 2 times 8 is 16. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8. Drop a 0. 1 times 0 is 0. 1 times 8 is 8. 1 times 3 is 3. 1 times 4 is 4. We have 0, 6, 15. We have 12 and 5. So they collected $52,560. There is our answer. You didn't need a calculator for that. Just 2 multiplication problems. Book thinks we're weak. Next page. Let's keep this going. We're kind of on a roll here. A farmer collects 1,250 eggs on a morning. She puts 30 eggs on each tray. How many egg trays does she need to hold all the eggs? Okay, let's sort this out. We underline a question. 1,250 eggs, 30 eggs on each tray. We need to divide here. 30 into 1,250. Okay. 30 can't go into 1. 30 can't go into 12. But 30 can go into 125. What's nice is counting by 30s is the same as counting by 3s. It's just a 0 at the end. So 30, 60, 80, 120. 4 times. Bring down the 0. 30 goes into 50 once. Minus 30 equals 20. So 41, remainder 20, right? If we were going to do a model for this, it would be very similar to the first one that we did. We would have a a bar. We know that there are a total of 1,250 eggs. We know each container holds 30. We just don't know how many there are. Okay? That's what that would look like. Now here's our dilemma. It said, how many trays does she need to hold all the eggs? It's different than that first problem. It's not how many are on that last one. So we know that there would be 41 that are completely full, but then we need one more tray to hold those 20 eggs, right? So we would round up. She needs 42 trays. Okay? That's what she needs. Next one, at a supermarket, pineapple juice sells for $1 per pint. Greg wants to buy 18 40-ounce cans of pineapple juice from the supermarket. How much does he have to pay altogether? All right, here's our dilemma. Well, first let's underline the question. We know it's $1 per 16 ounces. He buys 18 40-ounce cans. At first, this might look confusing because you're like, well, they're talking about pints and 16 ounces, but he's buying it in 40 ounces. We don't know how much that's priced. My assumption here, and I think it's a pretty fair assumption, is that they're saying it's $1 per 16 ounces. So we can find out if you bought, 32 ounces, that's twice as much. It would be $2, right? And so that's what we need to sort out. A couple ways we could do this. We could find out how much a 40-ounce can costs, or we could find out how many ounces he's buying and then divide by 16. It depends on what works best for you. Either works. So if you already know how to do this problem, go ahead and go forward. I think the best way I'm going to do this, I think I'll show how many ounces he's buying and divide that by 16 so we can get some two-digit division practice, and then I'll quickly show the other way. So again, he has 40 ounces each, and he's buying 18 of them. So let's find out his total. 8 times 0 is 0. 8 times 4 is 32. Drop a 0. 8 times 1 is 0. 1 times 0 is 0. 1 times 4 is 4. We have 720 ounces that he's buying, and it's $1 per 16. Okay. And again, I'm trying to think how to even the bar model would be. We don't know his total. We know that he's buying 18 cans, and each can is 40 ounces, but then also off to the side, 16 ounces equals $1. I think that's how we do that. 16 into 72. That's going to be tough. Let's round. All right, 16 rounds to 20. 720 just rounds to 700. So 20 into 7, or 2 into 7 is 3. So let's try it. 16 times 3. That is 48. That seems pretty low. Let's keep going. 16 times 4. Okay, 4 times 6 is 24. 4 times 1 is 4 plus 2 is 6. 64. I think we might be almost too far here if we keep going, right? If we did another 16, that would go past 72. So it goes in 4 times minus 64. That gives us 8. Bring down the 0. All right, into 80. Well, we know that times 4 would give us 64. Let's see if we can keep going. Times 5. That would give us, exactly 80. So he would have to pay, I almost didn't write a complete sentence. He paid $45. Again, all we did was we found out the total amount of ounces that Greg was buying and then divided by how much they cost, which is 16 ounces, $1 per 16 ounces. The other way you could do this is find out that, well, 1 pint, or it's $1 for 16 ounces, which means it'd be $2 for 32 ounces. And then if we knew this math, now this might come in later with fractions and decimals, but some might have been able to pick up on this, is that half of a pint is 8 ounces, right? So half of $1 is 50 cents. You need only 8 more ounces to get up to 40. So it costs $2.50 per can that he's buying. And then you could just multiply that by 18, and that would also give you 45. But that's getting more into fractions and or decimals. And we're not touching on that yet. So if you got it that way, awesome, great job. I think this is probably the best way we could have done it, was the way we did. All right, next one. We have another one with a calculator. Don't need it. A charitable organization spends $4,500 giving out food vouchers to families. Each family receives one voucher worth $25. How many families are there? All right, so again, this is similar to some of the ones we've seen. We know the total of $4,500. We know it's in groups of 25. We just don't know how many groups there are. All right, important information they spent. All right, we can circle those. Let's just worry about A. So again, we're dividing again. 25 into 4,500. 25 can't go into 4. It can go into 45 once. Minus 25 gives us 20. Bring down the 0. 25 into 200. Now, you might not know your 25s off the top of your head, but if you know anything about money, it's easy to count by 25s, right? 1 quarter is 25 cents, 2 is 50, 3 is 75, 4 is $1. Well, if $1 is 100 cents, $2 is 200 cents. How many quarters do you need for $2? 8, right? Or 4 2 times. So minus 200 equals 0. Bring down the 0. And 25 goes into 4,500. 180 times. There are 180 families. That's for part A. So let me go ahead and show that. So we saw that we were grouping 4,500 into groups of 25, and we just divided to find how many families there were. This is for B. Each voucher will be worth $32 next year. How much more money will the charity need next year? Well, if it's the same amount of families, let's see how much that would cost. 180 times, now it's 32. 2 times 0 is 0. 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. Drop a 0. 3 times 0 is 0. 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. Add them on up, we get 0, 6, 7, 5. They'll spend $5,760. But is that what the question's asking? It says, how much more money will they need? Well, they spent $4,500 last time. This time they're spending $5,760. So that gives us a difference of $1,260. They will need $1,260 more next year. Not a great answer quite well. 1,260. Okay, we're only have a couple left to go. Okay, a group of tourists visits an art museum. The admission is $13 for each adult and $7 for each child. There are 10 adults and 18 children in the group. How much do they pay altogether? All right, so first let's underline the question. How much do they pay altogether? We know 13 for an adult, 7 for a child. There are 10 adults and 18 children. Let's sort this out. So we have 13 10 times, right? We could show that as a box, right? It's $13. We don't know the total. That's what we got to figure out. But we know that there are 10 boxes. And then same with over here. We have 18 children, and it's $7 each. So we could, again, show our box. We know that there are 18 boxes. We don't know the total, and we know that it is $7 per box. Okay, so let's solve. 13 times 10. Well, we know that from earlier in this unit. Just throw a 0 on the end. 130. And then so that's how much the adults are. $130. For the children, 7 times 8 is 56. 7 times 1 is 7, plus 5 is 12. So $126 for the children. It's asking for all together, so let's add it up. They pay $256. There we go. Okay, almost done. Last page. The length of a rectangular board is 10 centimeters longer than its width. The width of the board is 26 centimeters. The board is cut into 9 equal pieces. Okay, so again, we have something. Let's look at it. So first question is, what is the area of each piece? So we're going to underline that. Now this requires some review. If you don't remember how to find area, is length times width. All right, And so what we're going to do is we're going to draw a rectangle. We know a few things. The width is 26, so we can automatically take that. So we know 26. It says the length is not 10 centimeters, it's 10 centimeters longer. So 10 more than 26 is 36. All right, so we have a rectangle that is 26 by 36, and those are technically interchangeable depending on how you turn the rectangle. But short part's 26, long part's 36. We cut it into 9 pieces. Now, 26 can't be cut evenly into 9 pieces, but 36 can, right? It is divisible by 9, so we're going to cut it along with 36. Okay, it's kind of sloppy, but there we go. We have those 9 pieces. Okay, so they're all 26 centimeters tall, but then we got to divide 36 into 9 sections. 36 divided by 9 is 4. So these are all 26 by 4. And 26 times 4 equals 104 centimeters. And it's area, so centimeters squared. It's going to be one of the exceptions where we don't necessarily need to write a complete sentence, but you could say the area of each piece is 104 centimeters squared. Okay. And it said, what are the possible dimensions of each piece? Dimensions are, again, the length and width. Well, guess what? We already wrote that in A. 26 by 4. There we go. Easy peasy. All right, last one. We have another calculator problem, but we don't need that calculator to solve this. There are 912 yellow chairs and blue chairs all together in an auditorium. The blue chairs are arranged in 36 rows and 12 chairs in each row. I always get rows and columns confused. Anyways, the yellow chairs are arranged in rows of 20. Okay, so again, how many rows of yellow chairs are there? So let's figure this out. We have blue. We know the total, we know the blue, and we know the yellow. So let's kind of separate them out. So we got blue, we have yellow. We know that there's a total of 912. We know for the blue, it's 36 by 12. And for the yellow, it's something by 20. So let's find out how many blue chairs are. If we have 36 groups of 12, let's solve that. 36 times 12. 2 times 6 is 12. 2 times 3 is 6. Plus 1 is 7. Drop a 0. 6 and 3. That gives us 432. So there's 432 blue chairs. We don't know how many yellow yet, so let's try. If we know that there's 912 total, and we know there's 432 of them are blue, let's find how many are left that could be yellow. 2 minus 2 is 0. Need to borrow. 11 minus 3 is 8, and 8 minus 4 is 4. There are 480 yellow chairs. They're each in groups of 20, so let's divide that out. 20 into 480. What's nice in this case is we can cancel those zeros out. 2 goes into 4 twice. 2 goes into 8 4 times. There are 24 rows. There are 24 rows of yellow chairs. Okay. I know I went a little quickly through some of these, so feel free to go back and look over them. If you have any questions, anything like that. So there we go. That is it for word problems today.